Hello, everyone, and welcome to Control Automation Day 2023. We are proud to deliver this keynote presentation from Phoenix Contact, sponsored by Mouser Electronics. For most experienced engineers, the recent trend towards the digital transportation and storage of data brings many new challenges, particularly in digging through the layers of often vague terminology in order to determine the best path forward. Perhaps this is most clearly illustrated in the very term IoT, meaning the Internet of Things. I'm excited today to learn about the innovations that are now possible thanks to emerging technologies related to this year's Control Automation Day theme, which is IIoT, and the progression of all kinds of digital transformation concepts. We'll be speaking today with Dave Eifert, the Senior Business Development Manager of IIoT Technology for Phoenix Contact, to learn about the process of coordinating the efforts of the entire team to begin a project effectively, allowing it to grow and mature to success. So welcome, Dave. Thank you very much for joining us for Control Automation Day 2023. We're excited to have you join us today.
David, I'm excited to be here. Thank you for the invite.
So as we get started, I'd just like to learn a little bit more about you, and in particular, what's the educational background that you come from, and then professional background as well, that sets you up for a job in this kind of industry where we're kind of putting this hardware and software together with the ultimate goal of optimizing these industrial systems?
Okay, good question. Well, the educational background goes back quite a few years now. It seems amazing to me that it's so far in the past. But I think it was actually a good platform from which to start. And that was at the time called industrial distribution, but a more apt title for the major came about after I graduated, which is interdisciplinary engineering and management. So it had aspects of both engineering and management. And I think that really suited me well throughout my career because I've always been in that kind of space between technology and the marketing or sales or application thereof. And so it's kind of valuable to be able to see kind of the business side of things, what the real benefit intended of the technology would have been, and then know enough about the technology to see how that could be prescriptive to maybe solve a problem instead of getting too deep down into the technology for the technology's sake. So I think it's been very instructive from that standpoint. So um, that was from Clarkson University up in New York State and a bunch of years ago, but I think it's served me pretty well throughout the career. And then in my career, it's always been kind of that high tech flair to the products or the systems or solutions combined with some kind of a sales or marketing or business development angle. And at points in time, it's been trying to sell it to the C-suite of different customers, and other times it's been more like the controls engineers or IT. So pretty wide array, and I think it's a really good um, school of hard knocks to have to kind of feel the pain of the folks out there. And then, you know, I think one of the problems with IoT and digitalization and things like that to start with was that some people got caught up in the buzzwords and trying to sound like the smartest person maybe in the room and forgot about the poor person who had to be the practitioner who applied it to actually do something useful. So I think that's something we all need to keep at the top of our minds is to okay, how is this really going to make somebody's life better and in a sustainable type of way.
I know that's a bulk of our discussion here today
Hmm.
is peeling away some of those layers of buzzwords to really get down to the how and the why and the where. Now, in a
Yeah.
company like Phoenix Contact, you're constantly working with different teams to not only develop the products but also learn how they best apply in certain
Hmm.
situations. So I'm just kind of curious, what are some of those projects, the really engaging projects that excite both you as well as the engineering development teams the most?
Yeah, that's a very good question. And it's such a dynamic environment. So there's always the ability to find the coolest, next, and most powerful either protocol or um, some kind of a API or some means of communicating with another, um, probably a third party or some kind of a cloud and so forth. So the real interest in my mind comes from finding people who are best in class in whatever domain they serve, whether it be knowledge, maybe it's a pump manufacturer who knows more about pumping curves than we ever would know as an automation provider. Maybe it's a cloud provider that knows how all that stuff works better than we could ever know. Maybe it's somebody like Arlen Nipper, a gentleman who a number of years ago, along with Andy Stanford Clark, created MQTT, and now Sparkplug, and getting to know them and figuring out how we can make our products work with that protocol, which is very lightweight and suited for IoT type of applications. And how does that all come together? And so to me, that's probably been the most challenging but rewarding side of, in general, of trying to make this all work, is to recognize that really to be successful, I think societally, is to have an ecosystem that can play together in an open way to get to the ultimate end of, making this easier, better, more resilient for everybody. So that's kind of like an overarching thing. And then if it comes down to specific use cases or projects, one of the ones I like to think back on was we were approached by a company that got involved with water management, and they had a subsidiary that got involved in fracking water because the fracking process uses a lot of makeup water to inject down into the wells and to break up the rock, and then they extract it out along with the product, and then they have to recycle the water and so forth. There's a whole bunch of stuff going on there, and oftentimes they get their water from an established water body, and that puts them under the crosshairs of the U.S. government in some kind of a way. And really, the U.S. Geological Survey is the ones who are in charge of that whole process. So um, they stipulate to these frack water producers that, okay, you can draw from this river, but only under certain circumstances, and those have to do with the flow rate of the river and the stage or the height of the water in the river. And if they're below certain thresholds, they're not allowed to pump. If they are above certain levels, they can pump, and they'll typically pump into kind of a retention pond, kind of like a storage, so it doesn't have to be just in time. Um, so in the past, what they used to do is actually have somebody. Oh, and by the way, U.S. Geological Survey doesn't allow you as the producer to use your own gauges, your depth gauge or your flow rate. They say we have those already installed, and we are monitoring those and bringing them up to the U.S. Geological Survey webpage. And they make a nice API to their webpage that you can go. Well, what most people do is they just go to the webpage and look at it and say, okay, it looks like we're good. Let's go hit the push button that says pump, and they'll do that. And then they have to have a couple people at the pumping site to make sure everything's actually working properly. It's very labor intensive, but a lot of downtime for the people who are there. It's kind of boring. They just watch a computer screen and then press a button, or they don't press a button and they sit around the rest of the time. So what this company wanted to do is automate the whole process. So what we were able to do is we have this product called the PLC Next, and it's basically a PLC on one side, and on the other side, under the same hood, is a Linux box, like a typical Linux PC, so to speak. And because it's Linux, it can do all kinds of cool things with open source software, such as Node-RED. And so we did leverage Node-RED. We went out to using the API from the U.S. Geological Survey. We were able to kind of scrape the relevant data from their website, bring it into the PLC, and then put it into Node-RED that could kind of strip out the relevant stuff that we needed and massage it a little bit so that it got into the proper format. And then we were able to pass that from the Linux side to our PLC Next, the actual PLC side, where we treated it as though it was an analog input. So it was almost like we had an analog input on our PLC reading the actual gauges from the river. And then based on how it was programmed and what the rules were of engagement, we could either pump or not pump and send the signals out some analog outputs to run a VFD at the proper speed, and either pump into the retention pond or not pump into the retention pond based on what the conditions were on the ground or in the river, so to speak. And the nice thing about it is you had a traceability record, so you can match up what U.S. Geological Survey was saying and what your actual records were showing in terms of when you pumped and when you didn't pump. So there's a regulatory kind of a trail there as well. And so it was something that freed up the guys who were on site to do more meaningful, more beneficial tasks for that company that were adding more value than sitting there in a chair, watching the river and then pressing a button. So I liked it because it was able to do a traditional IT kind of tasks, looking at a website from a traditional OT piece of equipment, a PLC, and also do the traditional PLC stuff at the same time. And it kind of combined a couple or two or three different elements into one box. It was pretty cost effective and did a really cool job. So that I thought was a really good illustration of where IoT can go to streamline and simplify some processes.
That one's really interesting because I guess when you think about data collection, probably most people think, well, you got to put a sensor in somewhere,
Right.
and maybe analog, maybe some advanced protocol, but there's a physical sensor somewhere, and sometimes you forget to think maybe somebody's already got that
Right.
gauge, that stream gauge somewhere, and the data collection can simply be a virtual call. And I think that's probably a little bit new or an unknown territory for a lot of engineers who really just work with the sensors on a day-to-day basis. It's a
Yeah,
really
absolutely.
interesting element of collecting data.
I totally agree with you. And I think it speaks to a larger concept that we're all going to need to embrace. And that is that I think in the past, we all were kind of DIY. We said, okay, I need to, from soup to nuts, I need to collect the data. I need to process the data. I need to actuate some actuators, all the steps in between. And there wasn't this concept of sharing data. And so I think now, as we go forward into Industry 4.0, we can start opening up our minds and saying, well, let me focus on doing a value added task to this whole equation. So maybe it is that somebody's already created the whole program that I would have written myself before. Maybe becomes an open source program I can download from GitHub, and just use it in an open processing environment. Okay, so that offloads me from having to reinvent a wheel that somebody else has already invented. um, and maybe I can just put my little tweak on it and much more efficiently get to the end state of what we need to do, which is to control process in a more effective way. Maybe it's the program's already written and all I want to do is use it to train an ML machine learning model, and then draw a lot of unprecedented type of conclusions out of the data that's being generated or already has been generated, um, and benefit from it that way in unprecedented kind of ways. And I'm not sure if we have any ML or AI uh, questions coming up that I don't want to spoil, but if we don't have them specifically written out, I can expound on that part of it from this little jumping off point here, or else I can wait. Either way, it's good.
Well, I do appreciate the introduction to those kind of concepts because I think you mentioned earlier buzzwords, and
Hmm.
that probably is something that a lot of engineers kind of get tired of hearing after a
Yes.
while. And that DIY attitude of liking to understand and I guess it's control, so be in control of every part of your
Yep.
process.
Yes.
And sometimes this requires learning something
Right.
new or learning a lot of things new that you've never learned before. So some of those things certainly we will kind of return back to some practical examples of how those IIoT concepts are used in industry. But even the concept of IIoT
Hmm.
is a buzzword that's kind of thrown around. But when we
Yes.
dive down into looking at specific projects for companies, what kind of projects do you think or can you recommend as being the right fit to
Hmm.
help a company decide if they need to invest in IoT? I think getting to the point of actually installing software or installing hardware is a little bit down the road. So,
Right.
are there certain things that you could recommend in those first steps of analyzing that decision?
That's a really great fundamental question. Um, and I think you kind of mentioned these buzzwords and maybe engineers fatigue with some of the smoke and mirrors and so forth. And there's this concept that maybe some of your listeners and watchers have heard of before, maybe not, but it's called the trough of disillusionment. And with a lot of new technologies or a lot of new paradigm shifts, there's a lot of hype and a lot of buzzwords and a lot of excitement. And then things kind of like peter out and they almost like disappear for a while. And then if they have some validity to them, then there'll be a slow build, and then eventually they will kind of meet their promise and exceed that initial spike and interest. And all the buzzwords will have kind of burned off by then, and people will see what's really valuable, and they'll start using it. And I think that's what happened with IIoT or IoT in general. And again, IoT is just the industrial Internet of Things for your listeners. Um, but there was so much bluster at the beginning, let's say maybe 3 or 4 years ago, and I think maybe up until just very recently, people are kind of over it, and now they're starting to see that yes, there is some merit here. But I would say the best way to approach a project in general is first make sure there's some sort of executive buy-in for the project. Um, Secondly, though, then you take your scope from real wide and executive level and you bring it right down very narrow to a specific problem. So, what I would mean by that is a specific machine or a specific process. And I would recommend that you find one that's a troubled process or one that represents a lot of uptime if you could fix it in some way. And so then you set about applying IIoT as tools, not as an end in of itself, not as a cool science experiment or some cool technology, but as a set of tools that, when used appropriately, could possibly and hopefully will help that situation. So it could be OEE, overall equipment effectiveness on a specific machine. It could be, reducing scrap. It could be increasing sustainability or reducing energy use. I can give you an example. In one of our own factories, we were concerned about energy use in terms of trying to get closer to net zero and decarbonization um, for sustainability purposes. And we knew the biggest culprits in our plant, what they were. So we measured those first. So let's say out of a plant with 100,000 IO points, we looked at like 3% of the IO points because we knew that that's really where the big bang for the buck was. And so I would say, initially get the executive buy-in, start small, try to solve that one problem, measure it. You're probably going to have to iterate a few times. You're probably going to say, well, let's tweak it this way, let's tweak it that way, um, and then you get your learnings from that, and then hopefully you've had success. If you've had success, then kind of replicate that to the next machine, the next machine, next machine, or next process. And you can only really do that effectively if you've had that executive buy-in in the beginning. Because if you don't, you might just have one island of success and then no corporate will or money to kind of replicate that throughout the facility. So that's why it's important to get the executive buy-in up front. And then if you do have success, then it's easier to start scaling it. Um, if you don't have success, then that's why you try to start small and fail fast, and maybe next look for the next thing to try, or maybe look at the same process but try some different tools. And so those are the different approaches. And I think we used to hear more about uh, digitalizing an enterprise, like it was like some kind of big, huge initiative that you were going to start off at Industry 3.0 in an entire factory or an entire company's enterprise wide across the globe, and all of a sudden you're going to come in and have these consultants and everybody, and at the end of 18 months or something like that, you're going to be Industry 4.0 because you will have revolutionized everything. Well, I don't think that's really I think it's too high of a risk and too interruptive of a methodology to even attempt. So I think it's more like iterative steps. And then one of the things that I've found is that, like in our example with our own factory, when we were looking at energy management, we found a bunch of other benefit in the shadows of the energy data. So we were looking at energy data exclusively at first and trying to find out how we're using the energy and where the little starts and stops were, and where we were inefficiently starting stuff up or shutting it down too quickly or leaving it on too long, and all that kind of stuff. And then what we found in the shadows of that energy data was a bunch of anomaly detection that told us a lot about our process and how that could be optimized to reduce downtime and to increase throughput. So we actually saved energy, but at the same time, we were able to increase throughput. And that was really enabled by some machine learning and some AI, artificial intelligence. And that wouldn't have happened if we hadn't been gathering the data for the energy management side of it, nor would it have happened if we hadn't exposed that data to another stakeholder who wasn't even there at the beginning. And the stakeholder happens to be a data scientist that we hired after the initial programming started. But he came out with fresh eyes and a different outlook, and was using the same source data for his own purposes, and was able to find these other patterns, which we call anomaly detection. And that led to more efficient ways to actually use these machines without increasing the energy use. So I think that's a common thing that people can find is that once you have the appropriate data and are using it for a specific, let's call primary purpose, that there can be secondary or even tertiary purposes for that data that can then be harnessed and utilized for some benefit that you may not have even imagined at the beginning.
Well, even if you're just using data for the primary benefit that you intended, it sounds like it involves not just the collection of data, which is critical, but it's not the goal, nor is the analyzing of the data. It's critical, but it's not the end goal. So it requires a whole variety of skill sets that if you're really missing any of them in this IoT process, you haven't seen success. And I think that's something that drives engineers a lot is that DIY attitude is usually the result of, well, I did this and it worked. And
Yes.
so you mentioned failing small, and I just imagine myself in a project where I set it up, I ran it, and it failed.
Hmm.
That that really means that in these cases, patience and understanding of a process is really important because it may not work exactly as intended the first time, or the benefits may not be direct, but there's still benefits. And
Right.
learning that patience and that ability to adapt to new changing process parameters is really important.
Yeah, and it kind of underscores the importance of trying not to take too big of a bite or throw all your eggs into one basket in terms of, let's put it this way: if you had a chance to roll with one vendor, whether that be a hardware manufacturer, software manufacturer, or some kind of consultant, but their scope is really wide, and you had to invest a big chunk of money in that, and you weren't guaranteed success on the outset of the project, and it failed, you'd probably be in a pretty bad spot after that. So that's why I advocate starting with a smaller project, and I think it's best to not hem yourself in, but try to adopt open standards as best you can, like things that are interoperable protocols, standard type, maybe even open source solutions for some of it, so that you have some flexibility and that you're not so hemmed in if it's going down a blind alley, that you can still access that data or reuse some of the either hardware, software, or whatever else you've been using in another way if it doesn't go quite the way you wanted it to go.
Yeah, and two things there. I know that the cybersecurity could be an entire discussion on its own, but that's a big concern for a lot of people is as I'm sending my data somewhere off site, where does it
Mhm.
go? Who controls the data? And we could have passwords, but how can I guarantee that my data is actually secure? And I think of course
Yeah,
that's
that's a
a big
gigantic,
question for people.
gigantic topic, and it's one that needs to be asked and answered upfront
Yes.
because it could represent massive vulnerability that nobody wants. And as an IT person, if you're sitting there thinking, you know, maybe 15, 20 years ago, when everybody came into an office and they had a computer sitting on their desktop and they logged in, that was one thing. But then once people started bringing laptops home, and then they started to bring your own device like iPhones to work and then back home and so forth. That's kind of what we're experiencing now with industrial systems as well. When you have IIoT, that means you got sensors everywhere and they're all coming back to some other location. And some of these sensors are made by startup companies that are the next coolest domain experts in their field, and they got some really cool technology, but maybe they don't have much of a track record. So you don't know if you can really trust them yet or not. I'm not casting any aspersions because I'm sure some of them are fantastic, but it's just a concern that companies could have. So I think they need to go into it with their eyes very wide open and adopt some kind of a security framework that is well accepted, something from like NIST or ISA 62443 or some industry, accepted type of security framework, and make sure that they have policies, procedures, personnel, everything, a product, all that conforms to some security profiles that are relevant, firewalls, whatever it is that they need, VPNs, et cetera, et cetera. And so, when it comes to like the PLC Next I mentioned before, we've developed in accordance with IEC 62443. And there's some other dashes after that show that it's a product that was designed in accordance with this, but then it's got to be applied in accordance with those standards as well. And so you can do that by setting it up in a certain profile. However, when you do that, you're cutting down its capabilities eventually to the point where if you do it as tightly as possible, then you're not really talking to the outside world. So you got to find that happy medium where you're still able to comfortably communicate the communications you need to have and want to have while excluding those that you don't want to have. And so it's quite an art, and I think that's just an opportunity for the practitioners and people applying this to make sure they're talking to their vendors and understand that the products are up to it. But not only that, but then they also have to have that, like I said before, the executive buy-in should bring with it the corporate will of the company administering this to say we've got to make sure we do this in a way that's cyber secure and doesn't leave any vulnerabilities out there.
So now as we look at those challenges of security as well as the size of the projects, I know that scaling has been kind of a selling point
Mhm.
since the very beginning of IIoT. Every time you see a new system release, they always talk about the scalability.
Mhm.
Can you explain to us what does that actually mean to scale? And then when an engineer is looking at a project that's a small project to begin with, that's focused on achieving results, how can they design that while in the back of their mind, keeping that scalability in mind so that
Mhm.
they aren't stuck with one small successful project without the ability to take it further? Can you kind of walk us through how that scaling process might work?
Yes, I can try. I hope I can. The first and most important thing, like I mentioned earlier, is make sure you get the executive buy-in at the beginning of the project. That's going to give you the framework to actually know that you have a runway after you can demonstrate some success, not leave it as an isolated island. So that's the first and most important thing. Once that's done, once you've secured that, then you start down that path. Then I think adopting open standards is important. Either that or if you wanted to tie your horses to some other uh, or whatever, I'm not sure what the right acronym is, but if you wanted to put your fate with one vendor, you'd have to make sure it was a vendor who's had a demonstrated success of doing this in other places that you know that they could carry across the finish line. But I think the most important thing is if you start in your most impactful project you can, and then you eventually have success with that, and it starts to generate some positive cash flow out of the benefits that you've made, and you kind of get an infectious desire to continue it. That'll power people through a lot of the headaches that might be associated with continuing down that path. Um, and I think the important thing is not to scale it out to 100% of the entire enterprise. I think the important thing is to try to do it where it makes the most sense and has a good ROI. And I think as long as you're using traditional business metrics to show you where you should apply these technologies, that's going to help the scaling process. The other side of it is you have to make sure technologically it'll scale, and the technology side of it is, again, if you adopt things like I was mentioning before, a publish subscribe type of a model using a broker or something like that, some cloud architectures, these things are built to scale and they're made to handle a couple 100 million connections and things like that at scale. Um, we built something on an Amazon cloud. It's a very simple and a pretty small demo, and we intentionally overbuilt it just so that we kind of built in the ability to scale quickly and effortlessly once we got there. So we did that with a foresight going into it. And in the case of Amazon, we leveraged our internal IT resource, a DevOps internal IT person that we have on staff, rather than try to do it with our OT staff. Our OT guys, operation technology, your traditional controls engineers, smart guy and smart guys and gals, and they could have figured it out, I'm sure. But they may not have figured out in such a way with such forethought as to I want to make sure that this can scale pretty much effortlessly as we go forward. So um, when we talk about the cloud, if you get IT involved and you have a good working relationship with IT, and I guess that would be kind of almost a prerequisite to make sure that you could have good relations between IT and OT within your own company. And if you don't, to either outsource that capability or hopefully just work on that internally, because I think it really requires strong collaboration between those two groups to really benefit from the best of what you both of you know to ensure success. And I don't know much about IT or DevOps, but I can tell you that our DevOps guy from IT used something called Terraform. And some, if you got IT people listening to this, they'll probably say, "Oh, yeah, I know what that is." But a lot of OT people may not. From the way I understand it, is it's a way to actually do like cloud deployment, but in code, so that you can just change some code pretty readily in a very specified kind of a way, and then quickly make changes, revision control, et cetera, and deploy it, and then fall back from it if that's not an adequate deployment, and keep a record of it, and keep it on a Git repository if you want it there. And it just makes things very easy to track for revision control, and to be able to move forward and to fall back if you need to, and to have a very clear record of how everything was set up and deployed. And that would be opposed to the way a lot of people from OT might do it, which is going to Amazon's dashboard and start, you know, firing up EC2, computes and S3 buckets and things like that, and do it all kind of piecemeal and kind of tie it all together, which might be harder to handle with a revision control. So I'm way out of my depth talking about the cloud in this kind of a way, but from what I've gathered from our IT guys, they've found a best practice. It's kind of a well accepted best practice within IT for doing things like this. And from what I'm right here, it's very easy to scale as they need to scale, and also easy to do redundancy. And the way we set up our cloud was that it's redundant within a region, but also can go interregionally. If anything were to happen in the original data center, it could quickly just swap over to this other data center that Amazon maintains in a whole different state, and keep things up and running. So I feel very confident that we have redundancy and security all built in, and it's way overkill for today, but it's got us well positioned to grow into the future.
I I'm hoping that there's a good diversity of audience listening to this, including many that are IT professionals. I think that communication and coordination between those two worlds of the hardware and the IT communications, it's extremely important. And I know just from the data that we've collected from our site and our audience, a majority of them are primarily focused on hardware. So I think a
Mm-hmm.
lot of those concepts that you bring up, while many people may be familiar with those, are probably a little less known. And
Mm-hmm.
I'd apply myself in that same area. I understand hardware very well, but many of the emerging concepts of IT are quite new to me, but still learning. Keynote speakers and live sessions for Control Automation Day are brought to you by Mauser Electronics. As your design fulfillment distributor, Mauser is your authorized source for millions of components from thousands of leading brands. Come discover, design, develop. Now, as we talk about this evolution of hardware, what have you seen are some of the biggest changes, especially recently? Things seem to be changing very quickly, not just with the ability of technology, but also just the events of the world around us have kind of forced things to change quite dramatically. But what are some of the biggest evolutions in hardware? One thing that you mentioned a little while ago, the PLC Next, with
Mm-hmm.
its kind of processing capabilities that are located side by side with the Linux processor. So both that, wireless technology, those kind of things. What sort of evolutions have you seen and experienced in the recent past?
Mm-hmm. Yeah, really good question. Well, I think back to like 15 years ago or so, when maybe 20, the prevailing wisdom was, hey, Ethernet's great, but it'll never make it to the factory floor. It's just not deterministic, and it's not robust, and so forth. And now you go forward to where we are today, and where we've been the last 5 or 6 or 7 or 10 years, and Ethernet's increasingly almost everywhere on the factory floor. You look at things like DeviceNet being replaced by Ethernet IP. And you look at things like Profibus being replaced by Profinet, um, Modbus TCP replacing Modbus RTU in a large measure. So that all kind of already happened. So where we're going forward from today is a couple different ways. One is Ethernet's going even farther down into the actual sensors, or will be soon, and those will be things like single pair Ethernet and APL, advanced physical layer, for kind of more of a explosion-proof areas. So those really aren't here quite yet, but they will be soon. But you can use things like IO Link to kind of get down to sensors today and communicate with them um, digitally, even if it's an analog sensor, to configure them or to change their parameters and things like that. So I think we're going to continue to see reaching farther and farther down into the actual sensor level. And sensors will become wirelessly enabled. A lot of them already are, battery powered and so forth, for remote locations, especially. And pretty soon they'll be able to bypass an edge gateway or a PLC and go directly up to a cloud. And I think those are some very big trends that are happening. I think there's going to be a long transition period, and I think the edge gateways will be an important aspect in the whole equation for a number of years. I just think it makes sense in any kind of a dense environment to bring quote unquote dumb sensors back to a aggregation point, which could be considered a PLC in some cases or an edge gateway in other cases. I think another trend is that maybe just a couple years ago, the thought was, hey, let's pump this all up to the cloud and let everything happen in the cloud. And I think increasingly people are saying, well, let's try to keep things on the edge as much as we can and only send the relevant stuff up to the cloud that needs to be there. And that's for reasons of latency and also just kind of costs of sending stuff to the cloud. So, for example, a lot of the machine learning and AI that could only have been done in the cloud even a couple of years ago, a lot of that processing power is now resident right on the edge gateways and can be done on the edge of the network. And then you always have that age-old question of, do you even want to go to a cloud, an external cloud? Some people don't. And so having that ability at the edge, I think, is important. And then you have the multi-cloud people that say, I don't want to be beholden to one cloud provider. I want to be able to parcel this out to various different cloud providers. So I think it becomes important to be able to do as much at the edge, but to have that portability of doing stuff on the edge or the cloud wherever it makes sense at any given time. And but being have the portability that I'm not stuck in a specific cloud. I could do it in various different clouds if I needed to. So I see those as all being important topics and ever evolving and kind of ping ponging back between where they happen. So those are important things. And with hardware, another big thing that's kind of happening, um, kind of slowly actually, and I think it has to do largely with the pandemic and then some global chip shortages that kind of came out of that whole thing, and that is 5G. And 5G has been billed as this panacea that we haven't really seen yet. But with 5G, if you listen to TV, you think it's been out for several years and it's the next greatest thing. But really, the 5G that's been out in the consumer world has been release 15. And that's really not capable of doing ultra reliable low latency communications and a lot of the other things that are going to be so magical about 5G. So that's release 16. And those chipsets are only really just right now starting to come onto the market, which means finding their way into products. So the products that feature those chipsets may not even really be out and available yet, but they will be soon. Once they are, that will enable like real-time communications on a factory floor, um, a bunch of other benefits as well. And that's when we're going to start to see some interesting things, I think, happen. And as an example, one of the promises of Industry 4.0 is mass customization, or there's different names for it, but the essential idea behind it is that instead of Nike, as an example, producing a million of the exact model of a certain shoe, every pair of shoes coming down the line can be customized by the user, from the internet or something like that. And to do that, they're going to need to have a lot more manufacturing flexibility than they have today. And part of that might be rearranging the actual way the factory is configured to enable some of this stuff. And right now, with the wires running between everything, it's kind of hard to do. So if 5G can become a reality and these machines can be enabled and you can do motion control and you can do all kinds of fancy high speed deterministic things over 5G as opposed to over actual cabling, then we can see maybe a real revolution in manufacturing actually start to occur. So I think we're going to see those things starting to happen in the next 2 to 3 years. And I think it's the type of thing where There was a lot of hype about it, and it never really came to pass so far. But I think we're starting to catch up. The technology actually starting to catch up today, and I think it'll be a slow roll at first, and then I think it'll almost go kind of exponential as companies actually see how they can deploy this and the real benefits they can derive from it. I think it'll really catch on, and maybe 5 years from now might be really an important part of the market. And again, by 5 years from now, we'll be past release 16, we'll be into 17 and 18, and even have more features with 5G and with Wi-Fi 6 as well when that really hits the market.
Well, certainly comparing the industrial market of components versus the consumer market, it's obvious that industry does not change things dramatically nearly as quickly. Um,
Yes.
and part of our challenge here is providing education, but editorial content too, as
Hmm.
you mentioned, like single pair Ethernet, 5G, things like that, is kind of knowing when to sort of tread that line between what's just a hype and what
Yes.
what can we genuinely provide education about versus fostering some of these buzzwords and adding to the confusion of the competing standards and things that might just be kind of a flash in the pan. So
Right.
always an adventure for us to publish the right information that's actually useful for engineers.
Yeah, and it's really difficult because if you were to believe the people espousing this information, you would have thought that 5G was a valuable commodity for the last 4 or 5 years, and it's really been mostly like a 4.5G, okay, for the consumer market, and we're really probably just going to see the fruits of it, like I say, any time starting real soon. Um, but there's so many things to consider, frequencies, the higher the frequency, the better the throughput typically is, but much really a penalty on the range. So it's going to be have to really find a sweet spot there and really see what works and how it can be deployed in an effective way. And one of the things that this calls into mind is a lot of people might think cellular. They might think there's a cell tower from Verizon or AT&T or T-Mobile or somebody out there 4 miles away. Well, that's not the one you're going to be accessing for this high speed 5G. You're going to have a private 5G network deployed right in your plant, and it may be managed by a Verizon, as an example. Um, it might be provided as a network as a service that you pay them for monthly or in some other fashion. But the actual hardware will be sitting there most likely in your plant because it'll have to be just to get the kind of throughput and reduce the latency to where it's going to be actually effective for you. So it's going to create a little bit of a mind shift. It's a little bit more like deploying Wi-Fi at that point in terms of the distances involved and things like that. But I think it'll be administered most likely by a third party, not probably. It won't probably be the owner of that plant buying the 5G equipment and standing it up and working it themselves. So it'd be a little bit of a mind shift in terms of how that's provided, in my opinion.
Now, you talked earlier about the buy in not just coming from the top, even though that's important, and not just coming from the bottom. Both groups are important in the process of moving forward. But for our audience, it's primarily going to be the engineers who understand the equipment. They understand the
Mhm.
processes that they're working with. So, as an engineer, or maybe a senior engineer, somebody kind of in that engineering management role, at one of these small or medium sized
Mhm.
companies that doesn't have some huge department that's going to do the deployment for them, what physical steps can they take if they've decided, I'd like to start thinking about deploying some of this technology, but I have done nothing to prepare for it? What first
Mhm.
steps should I take to make sure that I'm starting successfully?
Yeah, really good question. Um, I would think my first comment on that would be let me identify as even as the engineer, even though I might be responsible for technologies and not necessarily the process itself, but to try to understand the processes within the plant or within the environment to the point where I know where the problems are. Once I know where the problems are, that can start to inform a solution. What would I like to see changed about this process? What do I want to increase throughput? Do I want to reduce energy use? Do I want to do X, Y, Z? And that might be require a discussion with production planning or with quality engineering or somebody. But I would try to understand that first. That's really the motivation, and because you're really trying to make life better at the plant, not just deploy technology for technology's sake. Once you've gotten that understanding, then I would say it's time to decide what the rough elements are to realize some benefit there, or at least understand the situation better. So typically, what you need to do is monitor the situation and get some data from it, and then try to understand that data. What is it telling us, and what clues is it giving us as to what the problems really are? It's like getting a stethoscope out and sticking onto the machine. Okay, that's what you need to do. Listen to the heart rate of the machine and hear that murmur, or hear something else, or rapid pulse that shouldn't be there. And that's why you're instrumenting these things with sensors and then sending it somewhere. And then, you know, so what that brings to mind, well, one of the cool metrics that we learned from automating, or I guess IoTifying our own plant with the purpose of energy management at first, was that we found just 3 to 5% of the IO that we already are monitoring to run the machines, only 3 to 5% of those are what we needed to really listen to pick up, these vital signs from our machines. So um, I think in a lot of cases, um, the engineers probably have machines or process equipment that's already being monitored just to run the process. And it might not require additional sensors. It might, but it might not. So first of all, if you think it's some kind of a situation with you're trying to do preventive maintenance rather than reactive maintenance, maybe vibration sensor might be important. So if you already have a vibration sensor for some purpose, maybe you can harness that. If you don't, maybe that's an investment you need to make. Energy metering, same thing. Maybe you already have energy metering going on, CTs or something like that, monitoring some currents. If you do, that's great. Maybe we can use your existing PLC and just tap into it, communicate to it to an edge gateway. If you don't, then maybe you have to retrofit with some Rogowski coils or CTs or something to pick up those electrical signals. Um, so I think the first thing is to sensorize your equipment if you need to, or figure out if you've already got all the data kind of percolating in your system already. In that case, figure out if you can tap into your existing PLC or control system and pull that out. And in general, I think it's a best practice to apply your IIoT system as a parallel system around your existing control system. That way you can have the rest assured. You can tell your production planning people and your people, your plant manager, that hey, we're not interfering with the production here. We're not going to replace anything. We're simply putting a stethoscope around the existing thing, and that can again be just pulling data out of the PLC via some communications protocol, or sensoring it with additional sensors. But then get it into its dedicated system that you can look at offline, so to speak. And that should allay a lot of fears and risks associated with the system. So again, probably 3 to 5% of the things you're already monitoring is all you're going to have to do. So you're not going to have to instrument it with a billion sensors, most likely. Get it into an edge gateway. The edge gateway can store the data locally, or it can just relay it on. It could relate to a cloud, or it could relate to something on premise. If it's on premises, that means you've got to have some kind of a place to put it, a database or a SCADA system or something like that. If you've already got that, great. If you don't already have that, then it might be easier just to go to a cloud, an offsite cloud. And there's a couple of options. I always advocate, if you are an engineer that doesn't know much about IIoT, doesn't know anything about cloud, doesn't have the ability to invest yourself in learning a lot about that stuff right off the bat, I would recommend going with kind of an end-to-end solution that basically provides you, as long as you have the sensors, or it can tap into an existing PLC to get the data, it will then kind of take it from there, get it to a cloud in the appropriate format, create it, have a dashboard that's kind of a standard dashboard that you can kind of customize a little bit with like low code, no code, just kind of click and drag, and then set up alerts and alarms very simply, and use your own language, not some fancy, computer jargon to do all that kind of stuff. And that'll give you an output that you can readily use without knowing a whole bunch about IoT or cloud, et cetera, et cetera. So that's one valid technique, is what I call an end-to-end solution. Um, if you are already knowledgeable about cloud and you say, hey, all I need is a way to get data from here up to a cloud. Once it's to a cloud, I understand S3 buckets. I understand EC2. I understand Lambda in Amazon world, et cetera, et cetera, et cetera. I know how to do ML and machine learning and AI up in AWS or Azure. If you know how to do that stuff, great. So all you need was an edge gateway that can get you there. Um, so it kind of, I would look at it in two different ways. One is, hey, I am somebody who understands my process pretty well, but I don't know IIoT or cloud. Let's go with an end-to-end solution. Conversely, if I'm somebody who understands cloud or is aspiring to do that, I just need a piece of hardware called an edge gateway, and that makes it easy to get to a cloud of my choice. And then once I'm there, I'll do it myself. So the second way is much harder for most controls engineers, I would say. Um, so I'd recommend starting off perhaps with a end-to-end solution and kind of just having all that hard stuff figured out and done for you, and then all you have to do is kind of do some low code or no code configuration to get out of it the data that you kind of need. And then as your needs change over time, maybe you transition from the ready-made end-to-end solution to more of an open-ended one where you start to deploy stuff in the cloud as you learn it. But that can be something that happens later.
And I think that concept of learning, I know people do not have free time.
Hmm.
That's never a complaint that I hear from engineers is, boy, I just have all this free time. I don't know what to do with it.
Hmm.
But I've always kind of been a believer in the more you learn about something, the better off you'll be in being able to recommend and make an effective decision. And probably one of the worst things that you can do is say, I don't know what to do, so I'm going to allow just anybody to come in
Hmm.
here and quote me anything to solve this problem. And I guess that quoting and paying
Yeah.
ROI is a huge thing that for an engineer, the goal is things at the process level are better, but the
Hmm.
return on investment is something that everybody's going to be expecting. So, what
Right.
sort of costs are associated? You said sometimes the sensors are already there, the
Hmm.
controllers are there, and maybe an edge gateway with the ability to send either the computations at the edge or up to the cloud. What kind of costs then are associated? Somebody's got to be making some money somewhere, but what kind of
Right.
costs are associated with the deployment of an IoT project that might affect how that ROI calculation happens?
Yeah. I mean, the cost can really run the gamut, but I would say, let's just say, as an example, you were a wastewater treatment facility superintendent and you had a remote pump station that wasn't attached to a SCADA system for some reason, very remote or it's new or something like that. Um, and you needed to monitor that pump station. And what you wanted is some kind of a dashboard that you could pull up on your iPad. And you wanted your personnel, your operators, to get an alert or an alarm based on certain conditions becoming true, like a high level alarm or low level alarm or motor bearing temperature problem or vacuum problem or an intrusion detection if somebody broke into the facility. So and you just want that to happen in pretty much real time. Um, something like that. What you would be looking at is if you didn't already have those sensors, you'd have to buy those sensors. Probably talking about $1,000 or something like that for that. You likely already have the sensors because just to run the pump controller, you're going to kind of need them, whether it's an analog, you know, um, gauge, a gauge, or just floats, whatever it is. You've already got that just to run your process. You probably already have a PLC or some other pump controller there. So the point is, can that thing talk some kind of industrial protocol to an edge gateway? And if that's the case, then all you really need is the edge gateway. In the case of our PLC Next, which is the one I know best, it can be used as an edge gateway. So the PLC Next by itself is just a blank slate. Okay, we would take one of those to the tune of probably five or six, $700, something like that. Um, if you didn't need any I/O to come into it, you just use the base unit, and then you communicate over Ethernet to the existing controller, and then it gets into there, and we can use that as almost like a translator to get it from, let's say, Ethernet IP or Modbus TCP or something like that to something like MQTT or Sparkplug. And then we'd have like a cellular modem next to that. So we maybe have, say, a $600 device and another $600 or $700 device. And then we would direct that up to a cloud. And what we would probably do there is a very specific end-to-end system type of a cloud, rather than just go to AWS or Azure in general. We might go to something like a Clearblade or something like that that has a predefined dashboard, and that all that would require us to do is work with the customer to find out which parameters do you want, and we'll name it in plain English and just configure that in. Not really a code type of thing, just kind of a click type in these parameters that we need. Something that would say, like, for example, Main Street pump station, high level alarm. Okay, Main Street pump station, low level alarm, et cetera, et cetera, et cetera. So for an investment of maybe $1,500 in hardware, and then an ongoing cost of, depending how it's deployed, could be like $50 a month or something like that for your cloud connectivity and your cellular connection. You'd have a solution, and that would be a solution for one pump station. If you had multiple pump stations, you'd have to decide, if they're so far apart from each other, do I need an edge gateway at each one of those? Or if they're close enough, can I use one edge gateway and monitor several at the same time? Um, and then the other variables that come into it is, if you are going via cellular, you might be able to aggregate and buy a pool of cellular data that can cover all those sites and reduce costs that way. So you can start it pretty inexpensively. And that's why I always advocate starting small with a very well-defined problem, test it, validate it, tweak it, iteratively change different things till you get it running just the way you want it, and then deploy it to the next one and the next one. And at some point you decide that you can't not do this anymore because you're getting such valuable data. That's far less costly, as an example, as compared to running a truck out there when you see an alarm, or suspect a generalized kind of alarm, or somebody drives by and sees a red siren or red light flashing on the top of the pump station. It's cheaper also than, as an example, buying a server, buying SCADA software, putting up a radio tower. If you didn't want to use cellular and you wanted to use something like 900 megahertz radios that you own yourselves, which is the way people did it in the older days. So yeah, you can get started very inexpensively and test it, validate it, and then scale from there.
Well, I really appreciate you putting those costs into the perspective of the hardware, but then also kind of some of those ongoing costs. And obviously there's variables, and no project you can
Right.
quote out a project here on a webinar easily like this. That's an impossible thing to do, but it is nice to be able to put those relevant numbers and details into where and when those costs are going to show up.
Yeah.
Well, Dave, I've really appreciated this discussion. This has been fantastic. I've learned a lot about some of the challenges and some of those solutions as well, particularly when it comes to the first stages of getting started with IIoT, which I think is where many of the people in our audience are right now. Hopefully many of them are already understanding or adopting technologies, but for those getting started, this discussion has been fantastic. Thank you so much for joining us to share your knowledge and your experience with us today.
David, it's been a pleasure, and I really appreciated being able to be on this production. I thought it's been extremely valuable, and appreciate all the really good questions that you had. So I hope somebody got some value out of it somewhere, and if so, I'm glad it was possible.
And thank you to our audience for joining us today for this keynote sponsored by Mauser Electronics. And once again, our sincerest thanks to Phoenix Contact and to Dave Eifert for sharing his time and experience with us. We hope that you will visit the virtual vendor booths and watch the other keynotes and live session events, all of which will still be available on demand after today, so that you can share the experience with anyone who may have been unable to join us live. Thanks for joining us for this Control Automation Day 2023 presentation, and we'll look forward to seeing you again very soon.